Isn't that a terrifying face? And that's how I start off the first lecture of the new semester. Now, for our first lecture back, a lot that we want to cover, but a lot of it is review. We're actually going back and we're looking at chapter 3, and we're looking at physical evidence. Now, I don't have all of our objectives up, but we've been talking about them in class. That we're looking at the importance of physical evidence. We are looking at the differences between class and individual evidence. We need to know the difference between identification and comparison when it comes to evidence, and we're going to look at that in detail here in this video. We also need to understand the importance of class evidence, because most evidence is class evidence. It's not CSI. There's not always some sort of DNA fragment that if they just test it and test it and test it, it unlocks all the mysteries and we find out who committed a crime. It's not like that. So we're going to look at the importance of class evidence. So let's jump right all in when we're talking about physical evidence. A lot of this stuff is going to be review. Anything could be important. It is so important when a person gets to a crime scene that everything is documented and anything that could possibly be evidence is taken, because you don't know how important something is going to be. And so anything can be physical evidence. And while there's not exactly a perfect list, we're going to look at a list of the most common types of physical evidence. And so the purpose of it is that so you can collect it and analyze it. But as I said, you don't know if it's going to for sure be important or not, because until it's actually back at the lab and analyzed, and then that's going to be decided by the jury, and the jury alone decides if evidence is really important. So we have our list of types of physical evidence: blood, semen, and saliva. This can be both still in an actual liquid form, or this can be where it's dried on an object or something along those lines. Okay, and those would be taken care of differently. Documents, written documents that actually have someone's handwriting on them, or just documents that lead somebody that lead a motive in a particular direction. Drugs, this would be illegal drugs. This could be over-the-counter drugs. Those would be important. Explosives, if you have an explosive device, or even residue. We'll talk about that in a minute. Fibers. This is important of putting a person at a particular spot. I mean, if you have fibers, nice, lovely purple fibers, that can be tested to determine if the purple fibers that you're seeing at a particular crime scene match up. Fingerprints, we'll talk about both latent prints later in the year, which is what we normally think of, where you dust for prints, and also more patent prints where it's maybe impressed into something. Firearms and ammunition, these go especially when you have spent casings, actual fired bullets, because they match the barrel of the gun that they are shot out of, but those are important. Glass, we're going to be doing glass analysis next unit. We're going to see how glass is an important part of physical evidence. Hair, you can find hair at a scene, but you got to make sure that that hair isn't from a crime scene investigator or an animal, or just from a friend who stayed at that particular place 3 weeks before. Impressions, when we're talking about footwear generally, or bite marks. Organs and physiological fluids. This is determining, if a person maybe has ingested a certain drug, or if they have a certain illness, even that maybe led to their death. Those things are important, especially in the post-mortem, the after-death, types of searching. Paint. Okay, this is especially big with wrecks, hit and runs. Paint comes into play. Petroleum products, if there are certain oils, or maybe even like gas. Okay, like gasoline. That's left over. Plastic bags, this is an interesting one, especially when you talk about trash bags. Trash bags are actually made in a one big long sheet, and that's why they're cut in the perforations. And so you can actually sometimes match up. Say you find a trash bag at a particular at a crime scene, and you have a suspect, you can actually go and take that trash bag and see if it matches the trash bags in their house, and determine if, because there's kind of lines and striations in the plastic, and you can determine if it matches up. Okay, end to end. Okay, there's actually been crimes that have been solved that way. Plastic, rubber, other polymers. This is also just trace evidence that you can see. Powder residues. We talked about that actually with our crime scene that we did in the back lab. Sorry, I'm trying to fly through these. Soil and minerals. This can put a person. You find a particular type of soil on someone's shoe that matches where a crime took place. That's really big, evidence. Tool marks. We'll talk about that. Forced entry. Did a person use a the edge of a hammer, the claw portion of a hammer, or do they use a screwdriver to try to break into a place? We'll be able to determine the difference of that. Vehicle lights. Okay, I don't know exactly, honestly, what they're referring to when it comes to vehicle lights there, but I mean, we'll talk. I know about the different composite glasses and stuff of that, and wood and other vegetative matter. There have been crimes that have solved where, like wood splinters, or a person, or they found the other portion of a piece of wood that a person was bludgeoned to death with at two different spots, and were able to match them up. So those are also important. And vegetative matter, like grass stains or grass particles and stuff that get on shoes and pants and things like that. Okay, so you need to be able to at least recognize that these are all the different types of physical evidence, and there's more, but this is the main categories. Okay, so let's fly through this. The examination of physical evidence by forensic scientists is usually undertaken for identification or comparison purposes. We're going to go through each of these in just a second. Here's the definition, but we'll go through it in more detail in a second. Identification is to identify or figure out the identification of the substance with as near absolute certainty as existing analytical techniques will permit. I'll explain that in just a second. You're basically just trying to determine what is the evidence. Okay. Comparison is where you're actually taking something, generally a known substance, and you're trying to actually match it up with a reference that might go along with a particular suspect or a particular place or something like that to determine whether or not they have a common origin. Okay, so identification, what is it? Comparison, do they match? Okay, so identification. The process here, and I think one of the examples it gives in the book, and maybe even in the slide here, is like drugs. Say you find a substance, you don't know what it is. You can go and test it and find out specifically what kind of drug that is. And so you have to have first testing procedures that actually work. Okay, like say heroin. There's very specific tests that you can do to determine whether or not a drug is heroin versus cocaine versus whatever. Okay, and so you have to have a test in place. You can't just make up a test. And so a known test has to be in place, and then once the test results are established, then you can record that and you can repeatedly prove the identity of those materials. Remember when we talked about history, in the history of forensic science, that people kept testing greater and greater to be able to determine if arsenic was in a corpse. People kept adding to the ability to test for that in smaller and smaller amounts. So second, it requires that the number and type, no, I will not restart. Even my computer hates me right now. Requires that the number and type of test needed to identify a substance be sufficient to exclude all other substances. So there has to be a test, and it has to be a good test, okay, that you can exclude all other substances. Then you can identify and say, that is heroin, okay? That is specifically blood, and not just blood of anything, but that is not animal blood, that is human blood. Okay, we have tests to be able to determine that. Common types of identification. Okay, crime lab deals with this with illicit drugs, gasoline residue, especially if there was an arson, okay, or something like that, or an explosion. We talked about blood, semen, hair, and wood. Those are very common in determining where you're trying to actually determine what species did it come from. Okay, doesn't really help if it's like, haha, I found a hair on the crime scene. This is going to be the game changer, and you find out that that's their golden retriever's hair. That doesn't really help. Okay, so identification, what is it? Comparison is more about determining whether or not that a particular suspect specimen and a standard reference specimen have a common origin if they match up. Okay, so they test them the same way, and this is also a two-step procedure. First, combinations of select properties are chosen from the suspect and the standard reference specimen for comparison, and then once they have examined it, then they try to determine whether or not they think that it comes from the same place. Now, role of probability plays into this, and honestly, this is where we're actually trying to determine what are the odds that something actually took place. Okay, the frequency of the occurrence of an event. Okay, so it's like flipping a coin. is one out of two. Okay, so it's a 50% shot, and so we try to determine the probability using comparison evidence. So this works sometimes, but with some things it's impossible. Okay, and so just an example though, when we're talking about comparison, okay, evidence versus identification. Let's say that you have a hair from a crime scene that you find, and you're able to take a sample from a suspect in that crime, and you're able to match up and determine that those hairs come from a common origin. They both come from that individual. That way you can actually match that up. Okay. We've talked about individual characteristics and class characteristics a bunch, and so we'll spend a little bit of time here. Individual characteristics. Evidence that can be associated to a common source with an extremely high degree of probability is individual. Now remember, it says high degree of probability, so it's not that something is for sure individual and for sure class. There's a spectrum, okay, depending on the probability. Class can only be for sure associated with a group, okay, not an individual person or thing. Okay. So we can't use exact math to conclude the probability, and so that's something that you need to know. And so, but with some things you can determine whether or not they're more probable or not. Okay. So examples: the matching ridge characteristics of two fingerprints. We can pretty much guarantee that fingerprints match up. There is a statistical amount, okay, that says where it's like 1 in 6 to the whatever 30th or 40th or something, that says that a person could have the same fingerprints as someone else, but it's never happened before. Okay. Random striation markings on bullets or tool marks. Okay, that's also a high probability. Okay, because a gun has a unique groove pattern inside, and when a bullet fires, it has that same pattern on it. Comparison of irregular and random wear patterns in tire or footwear impressions. Okay, you walk a certain way, so you wear your shoes out a certain way. And so if there's a footprint that matches that becomes an individual characteristic, the actual way that it wears. Not the footwear, but the way that it wears on the shoe. Handwriting characteristics is individual, as long as it's like things unique to the way that you're writing. Okay, but there's some stuff about that that's also class. Irregular pieces, how things fit together jigsaw-wise, that is also individual. Or as we talked about already with the plastic bags, matching the striation of running through the bags. That is also individual. Now, class characteristics. Some things you cannot actually, you cannot find their exact common origin with a high degree of certainty. Okay, it can only be associated with a group, and so probability is still the determining factor, but it doesn't narrow it down all the way. Okay, most evidence, and you need to know this, most evidence is has class characteristics. So, I'm sorry, I'm having trouble talking today. A little on the sick side today. Okay, so this is actually one of the current weaknesses of forensic science is the inability of the examiner to assign exact or even approximate probability values to the comparison of most class physical evidence. You can't say something is like with the purple fiber on my shirt, that yes, if I find this fiber, that it is a 1 in 378th chance that it goes along with the shirt. You can't assign an actual number to it. So that bugs people, especially when we're talking about science, that you can't actually give a quantified number to it. Okay, for what? I've given all the good examples. For example, what is the probability that a nylon fiber originated from a particular sweater, okay, or that a paint chip came from a suspect in a hit and run? So there's little statistical data available, okay, but some of it, it's still what you're going to see for the most part in court, okay. So let's see, class evidence. Okay, this is just kind of repeating what I said. Most physical evidence cannot be traced to one person. And so the value of class physical evidence lies in its ability to provide corroboration of events with data that are as nearly as possible free of human error and bias. Wow. Basically just saying that it's the forensic scientist's job to process the data well and for there to be as much evidence processed so that ultimately you can put it all together. Okay. The chances are low of encountering two indistinguishable items of physical evidence at a crime scene that actually originated from different sources. So odds are, okay, that if you have evidence there, that it comes from the same source. Okay. And so when you have more than one type of evidence, it makes it a lot more certain that it originated from the same source. Okay, does that make sense? Like along the lines of if there is a footprint pattern in the mud at a particular scene, okay, that's class evidence looking at the shoe, okay, but it also just happens to be that the scene is near a school that you go to, okay, and you're a suspect. Well, they test the foot pattern, and it's the same type of shoe that you have. That's the same school that you go to. Therefore, that kind of builds up and builds a case against you. Okay, and then ultimately, it's determined in the courtroom. It is not the judge's job, the lawyer's job. It is only the job of the jury to then determine that. Okay, and so this is where it gets a little fuzzy. Okay, where individual and class stuff kind of melds. Because how many striations are necessary to individualize a mark to a single tool and no other? Well, there's no answer for that. How many color layers individualize a paint chip to a car? There's not anything for that. How many ridge characteristics individualize a fingerprint? See, there's nothing that actually says, well, 11. Okay, and then for sure, that's the case. And so, I have students trying to come in. So these are all questions that don't have simple answers, and so people continue to kind of try to figure it out. We'll talk about that there's some natural variations. Okay, I don't know if we're going to talk much about natural and evidential limits. Let's see. Okay. Actually, I'm going to go ahead and we'll end this video for today. We'll end this one, and we'll put another video with natural and evidential limits up for the next class. And signing off.